This is the first video of 3. In this video we are going to look at moving a function left or right or up and down. These are called translations. Let's begin by looking at a warm-up. Here we have 3 functions, f, g, and h. What we want to do is first identify which of these 3 is the parent function. Now from our list of parent functions, we know that f is our parent function. It's the square root function. So f of x equals the square root of x is the parent function. Now we want to write g, in part b we want to write g and h in terms of f. So g of x equals, and what this means is if we look at f, our parent function, f says to do what to our input? Well, let's say that we put in 9. F of 9 means we're going to take the square root of 9. So f simply means take the square root. That's what this function's name is. So we're going to take the square root of the input. But in g, we're not taking the square root of our input. In g, our input is x, and we're going to take the square root of x minus 2. So if f says take the square root, then what are we taking the square root of in g? We're taking the square root of x minus 2. But instead of saying square root, we know that f says to take the square root of x minus 2. So g of x is simply f of x minus 2. Likewise, h of x is the square root of x plus 3, but instead of saying square root, we can say f. So h of x is f of x plus 3. You'll notice that in both of these instances, we end up with a change in our input. So for graphing f, let's look at our key points, 0, 0, 1, 1, 4, 2. Each parent function has some key guide points that can help us graph. So if I use those same values, it doesn't make much sense in g because there's a change in my input. So I need to adjust the inputs here so that we end up with similar values. So if the first thing that I'm doing is subtracting 2 from my input, I need to start with a larger value. So let's look at 2, 3, and 6. If I take the square root of x minus 2, then that's going to be the square root of 0, which is 0. Put in 3. 3 minus 2 is 1. The square root of that is 1. The square root of 6 minus 2 is going to be 2. Now, if we look at h, again, I'm changing the input of f, and I'm adding 3 to my inputs before I take the square root. So this addition of 3 means that I'm going to have to compensate by looking at smaller values. So let's look at negative 3, negative 2, and positive 1. And again, if I put those values in to h, and I'm going to take and add 3 and then take the square root, we get 0, 1, and 2. So what we're going to do now is we're going to take these points and we're going to graph them. So we'll graph f, which should be a familiar function to us because it's our parent function, the square root function. And then we'll plot the corresponding values, corresponding points for g and for h. So if we look at f, we had the points 0, 0, 1, 1, and 4, 2. And so there is our familiar parent function for f. If we look at g, we had the point 2, 0, 3, 1, and 6, 2. And for h, we had the point -3, 0, -2, 1, and then we had the point 1, 2. So you'll notice that, if you remember, h of x equals f of x plus 3, and that was a movement of our graph of f to the left 3. So this addition of 3 moves us left 3 because it's a change in our input, a change in our x values. And then, if we look at g of x, we had f of x minus 2, and that was a movement of f to the right 2 units. So we see the subtraction of 2 is a movement right 2 units. So we can put this together and obtain a rule. If we're adding a value to our input before applying our parent function, then it's a horizontal translation, and an addition of a value will move it left h units, whereas a subtraction in our inputs moves us right h units. Now let's look at what happens if we add or subtract after we apply our parent function. So in this instance, we have the same parent function, f of x equals the square root of x. But this time, g of x equals, now notice the subtraction of 6 happens after we take the square root of x. So we have the same input as we did with f. So we apply f to x, and then we subtract 6. Likewise, h of x equals an application of the square root function, and then add 4 after we apply the square root. So in each one of these, the inputs never change. So the inputs will still be the same as what we used for f. And again, those key x values for f are from our key points on our parent function. So now, whenever we look at g, if we plug in 0, we will get 0 minus 6. Put in 1, and the square root of 1 is 1, so 1 minus 6 is -5. And 4 we'll have a square root of 2 and subtract 6, and we get -4. If we add 4 after we apply the square root, then we will get 0 will become 4, 1 will become 5, and 4 will become 6. Now let's go ahead and look at the graphs. Again, this is a warm-up. We're moving towards a quicker way to do these than plotting a bunch of points. So f, we had our key points 0, 0, 1, 1, and 4, 2. And this is just our familiar parent function. For g, we had 0, -6. We had 1, -5. And we had 4, -4. So you can see this was a movement down 6 units. And if we look at h, we have 0, 4, 1, 5, and 4, 6. So we have a movement up 4 units. So by adding or subtracting from our output, we have a vertical shift or vertical translation. And this time, if we're adding after we apply, that moves up k units, and a subtraction, we move down k units. So let's look now at a different parent function, but we still have some translations going on. So if we have the parent function f of x equals the cube root of x, and so what's that look like? Well, we have our guide points. -1 goes to -1, 0 goes to 0, and 1 goes to 1. And it would look like this. What we want to do now is look at what happens if we rewrite y so that it is a transformation on f. So y equals f of, now what are we taking the cube root? Because that's what f says to do. F says take the cube root. So what are we taking the cube root of? In y, we're taking the cube root of x plus 1. Then after we're done taking the cube root, then we subtract 4. So what do we see here? We see an addition of 1 in the input, and then a subtraction of 4 after we apply the parent function. So this is the first thing that we do, and then this is the second thing we do. So the first thing, an addition of 1 in the input, corresponds to a shift left of that many units. So this is left 1 unit. And then secondly, a subtraction of 4 after the parent function has been applied is a vertical shift down of 4 units. So each one of these 3 guide points gets shifted left 1 and down 4. So if we move, let's start with the 0, 0. Let's move that left 1 and down 4. And then if we move 1, 1, left 1, and then down 4. And then -1, -1, left 1, and down 4. We end up with this shape.